This is clear. So this is how we proceed. So this is the basic idea of any transformation technique. Let it be Fourier transform or Z transform or Laplace transform. So what is the basic idea? The problem in one domain is difficult to understand or difficult to solve. So what do? We will basically convert its domain from one domain to another domain. In the newly converted domain, we will try to solve the problem. After solving the problem, we will take the inverse function, whatever we take. So if you are taking Fourier transformation, we will be taking inverse Fourier transformation. So this is something similar to that. So how can we understand the idea of any transformation? It is nothing but what? It's nothing but it's nothing but a function, guys. So we have some problem P. We are going to apply a function f on P, f of P, right, which takes you to the codomain of f, and we are going to solve the problem in the codomain and newly converted domain. And once we solve the domain, how can we come back to, once we solve the problem in codomain, how can you come back to domain? By taking inverse function, whatever we have applied. If you apply log, take anti-log. If you apply Fourier transform, take inverse Fourier transform. If you apply Laplace transform, take inverse Laplace transformation. So why did I explain about transformation techniques here? Because of this guy AlphaCat, right? Why do we need to study about AlphaCat? Here, AlphaCat is actually playing the role of transformation. So one side we have classical sets, another side we have fuzzy set. By means of this AlphaCat, actually, we can travel between classical set and fuzzy sets. So this is what the reason why we are really interested in studying about AlphaCat, especially with respect to the fuzzy number. AlphaCat refers a precise quantity. So fuzzy is basically an infinite quantity, but AlphaCat is nothing but what? It's basically a precise quantity. In another way, I can say that AlphaCat is nothing but crisp set. Now we are studying about AlphaCat to study about the fuzzy set, basically. So it is kind of a bridge between crisp and fuzzy sets. Now I'm going to introduce about fuzzy number. So what are fuzzy number? We know that the classical set can consist of any numbers, but what about the difference between the classical sets and the number sets? The number sets in which each element is nothing but a number, right? So the set of students, the elements are nothing but students, but the set of natural numbers, the elements are basically the natural numbers. So similarly, the fuzzy set can consist of element of any type, the group of people who are young, group of people who are rich, the top 10 cricket players in the world. It can consist of any element, can consist of people, numbers, objects, or anything. But what is the meaning of fuzzy number? So in order to qualify as a fuzzy number, a fuzzy set. So first of all, fuzzy number is nothing but a fuzzy set, because every number set is nothing but a set, first of all, right? So in addition to that, in order to qualify as a number set, the elements, all of the elements should be numbers. So similarly, in order to qualify as a fuzzy number, a fuzzy set must satisfy certain axioms or certain conditions, right? So first of all, every fuzzy set is characterized by means of a membership function. So in order to be a fuzzy number, first of all, the fuzzy set should be characterized by a membership function, where membership function mu a is a function from the set of real numbers to closed interval 0, 1. Any fuzzy set, the membership, the universal set can be any non-empty set. But in order to be a fuzzy number, the universal set should be the set of real numbers, basically. The R refers the set of real numbers. So where mu a is a function from the set of real numbers to closed interval 0, 1. So it's said to be a fuzzy number if it satisfies the following three axioms. The first axiom is nothing but, first of all, the fuzzy set should be normal. What is the meaning of fuzzy set should be normal? The height of a fuzzy set should be 1. In another way, I can say that. For example, let us recall the same example which we have considered, the group of young people, right? So if you see that particular example, you can see Jiva is exactly 25, who is satisfying the condition about 100%. So whose membership value is 1. So what is the meaning of fuzzy set to be normal? At least one element in that fuzzy set should satisfies the condition of being in the set about 100%. Here Jiva is an element of the fuzzy set of young people. This element Jiva is satisfying the condition of being in the set young about 100%. So this is what the meaning of normal. A fuzzy set is said to be normal. At least one element in that fuzzy set should have the membership grade, membership value 1. Now, alpha cut. Just now we have discussed the definition of alpha cut. Each alpha cut should be closed interval for every value of alpha in the closed interval 0, 1. Right? For example, you consider this. For this specific value of alpha, the alpha cut is basically the closed interval. Suppose if you consider the alpha cut here. Suppose if you consider the alpha cut here. Right? For this alpha cut, again you consider this as a straight line. I'm drawing using mouse, so it is not coming like straight line. So again, it intersects at this point, and its inverse image would be somewhere like this. Right? So this is nothing but the closed interval corresponding to this particular alpha value. Let us call it as 0.7. Let us call this as this alpha value is 0.6. So similarly, for each alpha value between closed interval 0, 1. So alpha can take value from where? It can take value from strictly greater than 0 to up to 1. So if you consider any value alpha which is between closed interval 0, 1, what can you talk about its alpha cut? It's always a closed interval basically. So with respect to this specific example, the alpha cut is basically what? The alpha cut for all values of alpha, it is basically the closed interval. And what about whether it is normal? Yes, of course, it's a normal fuzzy set because you see the elements which are lying between B and C here. All of them are having a membership value which is equal to 1 basically. And what about the third condition? The third condition is basically third condition is basically support of A is bounded. What is the meaning of support of A? It's nothing but strong zero cut. Strong zero cut. What is the meaning of it? I'm not interested in collecting any fellows who are satisfying this greater than alpha. I am considering only the elements which are satisfying strictly greater than alpha, which means what? I'm considering small x from here up to here. All the small x I'm considering except at A and B. A and B. This is what the meaning of support. Support means what? I'm interested in collecting the elements whose membership grade is strictly greater than alpha. What is the meaning of it? Inverse image of this entire curve. Inverse image of this entire curve. Right. So that is nothing but what? Except A and D, all other elements between A and D. So whether it is bounded, yes, of course it's bounded. It's bounded by first of all A and D itself. Right. So if a fuzzy set satisfies all these three conditions, then we call such fuzzy set to be fuzzy number. Right. So there are different types of fuzzy numbers are available, like real value fuzzy number, interval value fuzzy number, triangular fuzzy number, and trapezoidal fuzzy number. So now, why do we need to have, first of all, these different types of fuzzy numbers? What is the need of it? First of all, I'm unable to understand the fuzzy number. Then what is the need of interval value fuzzy number, triangular, trapezoidal? Let me answer you quickly. So how can you understand? See, real number 3, it is not cause and dependent, right? So if I'm saying that 3 is common to everyone, all of you would agree that if there are 3 fingers, then everybody will say that it's 3. It is not cause and dependent in nature. Suppose instead of that, if I'm saying around the 3, it is cause and dependent in nature. Again, if you are not getting it still, let us assume the scenario. See, at least some point of time in a day, we usually go to the market. If you wanted to purchase the vegetable of 1 kg, like let us say this brinjal, if you wanted to purchase brinjal half kg, how the shopkeeper will give half kg? Let us assume the scenario of the weighing machine, which is digital weighing machine. Is it like exactly the 500 gram they give? No. Most of the time you can see it's 505 gram, 510 gram, 550 gram. Like that only they will be giving. Do you agree with me? So if it is exactly 500, if you are saying give me half kg, if they are giving exact half kg, it is nothing but crisp set. But will they give exact half kg? No. Definitely like 505 gram, 510 gram, 515 gram, like that only. If you are talking about digital, if you are not talking about digital weighing machine, then what can you say about whatever the quantity which you are getting? So it's basically what? This is nothing but fuzzy number. Imprecise real number. So we have asked for half kg and he also wanted to give half kg only. But all the time or most of the cases, it will exceed half kg. It's not sharp 500 gram. It would be 505 gram, 510 gram. And at the same time, could he give, if you ask for 500 grams, would he give 600 grams? Definitely he will not give. Are you getting my point? Because the loss would be more. So it is nothing but what? Around 500. So every time he wanted to give around 500, and that around 500 will have some boundary. What it would be, shopkeeper might keep that, okay, up to 50 grams I can give, 550 grams up to that I can give, or 530 grams up to that I can give. So this is what the meaning of fuzzy number. And there is a boundary. This boundary consists of what? A, B, C, D. Here the boundary is nothing but what? Let us consider this example where D is nothing but 550 gram, and at the same time A is nothing but 500 grams. Right? So definitely we would not agree if he is giving less than 500 grams, right? For example, if he is giving 450 gram of brinjal, if we ask for, if we are paying for 500 grams, we will not take it. So there will be a lower bound and an upper bound. Now, the idea is nothing but what? In a real life problem, we are able to see that different types of fuzzy numbers are being used for model the problem. So what kind of problem should use what kind of fuzzy numbers? What type of fuzzy numbers? That is a questionable topic all the time. So how can we understand this triangular fuzzy number? And what is the difference between interval fuzzy number and a triangular as well as trapezoidal? Actually, all these numbers are generalization of each other. Interval value fuzzy number is a generalization to real value fuzzy number. In the interval, if both the ends are A, and for example, interval value fuzzy number means closed interval A comma B, a fuzzy number is represented like this. If A equal to B, it will become a real value fuzzy number. Now the triangular fuzzy number, there is a difference between triangular and interval fuzzy number. We wanted to consider this triangular fuzzy number. What is the meaning of it? This is nothing but around 5 kilometers. How much distance you have walked today? Around 2 kilometers, right? So it might be approximately 2 kilometers. So something less than 2 kilometers also you'll be considering. Something above 2 kilometers also you'll be considering. But at the same time, 1900 meters, you may consider it as a lower bound. Maybe 2100 meters as an upper bound. And 2000 is your main target. So it's nothing but what? Around 2 kilometer can be considered as 1.9 kilometer as your lower bound. 2 kilometer is topmost priority. That should satisfy the membership grade 1. And 2.1 refers the upper bound basically. And similarly, trapezoidal fuzzy number. It is nothing but what? It is nothing but the generalization to interval fuzzy number. So it's closed interval A comma B is nothing but an interval value fuzzy number. Around closed interval A comma B, it's nothing but a trapezoidal fuzzy number.